Hi everyone, it's me, Dr. V, and we're here to do some AP Chemistry exam review. It's always a good day to study for the AP Chemistry exam. In this webcast, we're working through free response question number 7 from the 2024 exam. Now there are some changes coming for the 2025 exam. This year, for the first time ever, the AP Chemistry exam is going to be a hybrid exam. You're going to take the multiple choice questions online in the Blue Book app. You will have scratch paper for that part. You're going to see the free response questions presented online in Blue Book, but you'll actually write your answers on paper in a paper answer book. And if there are any images or diagrams or charts that you need to work with, they'll be included in that answer book. Other things you should keep in mind: you will have a paper periodic table for the entire test, but the reference sheet, we love our reference sheet, but that's only going to be available digitally. You'll have to pull it down in the Blue Book app, and it is tabbed by topic. You'll also have access to the Desmos graphing calculator embedded into the Blue Book app. You'll also have use of your own approved handheld calculator, whichever makes more sense for you. So in terms of this webcast, how I like to set this up, we are going through free response question number 7. This is one of the short free response questions. There are 4 short free response questions on every AP Chemistry exam. This question scored out of 4 points. The short free response questions often have 3 or 4 parts to them, but they can also shift topics midway, so you need to be prepared for anything. Before we go any further, grab your calculator, periodic table, and your formula sheet. What I want you to do is listen to me introduce each part of the problem, and then I recommend that you pause the webcast and try to answer it on your own, on paper. Write your answers down, and then listen to my explanation, and then score your work as we go through it. Did you earn the point for that part? Did you not earn the point? How do you need to enhance your answer? Was there something you forgot? Keeping track of that helps you be a better chemistry student and helps you to better demonstrate your knowledge, which is the whole purpose of taking the AP Chemistry exam. All right, I'll get off my soapbox now. Let's jump right into the question. A student conducts a chromatography experiment and needs to prepare 100.0 milliliters of a 0.340 molar sodium chloride solution to use as the solvent. The first thing we're asked to do, calculate the mass of solid sodium chloride. Oh, and look, we're given the molar mass that we need to prepare 100.0 milliliters of the 0.340 molar solution. So thinking about the molarity formula is really where we want to start. Moles of solute over the total solution volume in liters. We can actually substitute the gram to mole conversion in here. So the grams of NaCl divided by the molar mass of NaCl divided by the liters of solution would equal the molarity. But we want to solve for the grams of NaCl, so I recommend at this point that you rearrange the equation to isolate grams of NaCl. And what we get is molarity times molar mass times the volume of the solution in liters. Well, we know all those. We were given the molarity of the NaCl. We were given the molar mass of NaCl. And we know the volume of the solution. We actually know it in milliliters, but we can divide by 1,000 to turn that into liters. So we can just substitute those values in, and we get an answer of 1.99 grams of NaCl. We do really want to report this to 3 sig figs. Not that that's our major concern, but we do want to pay attention to sig figs. We don't know which of the free response question parts will be scored for sig figs. Anyway, this is the work you need to show with the correct answer to earn 1 point for part A. In the following table, which I'm not actually showing it here because it gets kind of busy, briefly lists the additional steps necessary to prepare the 100 mils of the 0.340 molar solution using only materials selected from the choices given. Assume that all appropriate safety measures are already in place. Not all materials in the list may be needed. So we have all these materials and we need to figure out which ones we want to use to prepare a solution. So looking at the list right away, it's really obvious to me that I don't need chromatography paper to do the solution. I'll need the chromatography paper for the chromatography experiment, but not to prepare this sodium chloride solution. I'm going to need solid sodium chloride, obviously. We just calculated its mass. We're going to need a balance because I need to mass out the 1.99 grams of sodium chloride. I'm going to need distilled water. I'm going to need weighing paper and a scoop, but I have to think about what glassware to do this in. I want 100.0 milliliters. I want a pretty precise volume. And that means what I don't want are beakers. You don't want to rely on the markings of a beaker for precise measurements. No, 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 no. I need something that's more precise than that. The milliliters are often marked plus or minus 5 mils. That won't help me here. But I also need 100 mils. So the graduated cylinder is marked to 1/10 of a mil. but it's only 50 mils and I need 100. That's not a good choice at all here. My best choice is the volumetric flask, the 100.0 milliliter volumetric flask. And volumetric flasks are ideal for this kind of thing because the only measurement I can make is that line on the neck, which gives me 100.0 milliliters very, very precisely. This is the equipment that I want to use. The pipette, I'm not really sure how I would use it. I don't need it to do this, so I'm just going to not do anything with it. Okay, so let's go and look at the table to prepare solutions. Really what we're trying to get at here with this question is, do you know how to prepare a solution? Okay, so step 1, we were told use the weighing paper and scoop to measure the correct mass of solid NaCl in the balance. We already know how much that is. What's the next thing we should do? Well, we want to mix the salt with the water. So what you're going to do is put some distilled water in the volumetric flask, but not all the way up to the neck. You don't want to fill it all the way up yet, okay? And then you're going to transfer the solid sodium chloride into the flask. Step 3 says swirl the mixture to dissolve the solid sodium chloride. We need to make sure that final volume gets up to 100.0 milliliters. So at this point, I'm going to put more water in the volumetric flask. And ultimately, I want the bottom of the meniscus to be on the calibration line. And then I'm going to stopper and invert the mixture and ensure that everything's completely dissolved, that I have a homogeneous mixture. Now, really, my lab chemistry days tell me that I actually don't want to, in step 4, don't want to get all the way to the bottom of the meniscus. I actually want to stopper and invert and then add a little bit more to make, or if I need to get right on that line. So the bottom of my meniscus is right on the line, but that's not what the College Board asked. So that's not what we're going to do. Part B was worth 2 points. 1 point for your explanation in step 2. Put some water in the flask and transfer the sodium chloride into the flask. And then another point for a correct explanation of what to do in step 4. Put more water in the volumetric flask. Bring that volume up to 100 mils so that your meniscus is right on that calibration line from the volumetric flask. And then there's a whole chromatography thing going on. The student uses the sodium chloride solution as the solvent to separate a mixture of compounds X and Y in a chromatography experiment. After 30 minutes, the student removes the chromatography paper from the chamber, and the results of the experiment are shown here. So we have a start line, we have the solvent front, how far did the solution move up the paper, and we have spots for compound Y and compound X. A second student conducts the same chromatography experiment, but removes the chromatography paper from the chamber after 15 minutes instead of 30 minutes. Predict the effect, if any, this would have on the separation distance between compounds X and Y in the new experiment and explain your reasoning. So this is one of those questions where you need to make a claim and then back it up. So the original experiment that we were shown was the 30-minute runtime. If the experiment only runs for 15 minutes, I'm going to make the claim that the separation distance would decrease. How do we know that? How can we back that up? If I have a 15-minute runtime, the solvent front is not going to move as far. Let's say it only moved half as far. Y moves just about halfway in the original 30-minute experiment, so it's still going to move about halfway, and compound X moved a little bit less than that, maybe 40% of the distance, so compound X is going to move 40%, but the solvent front didn't go as far, so 50% or 40% are smaller distances, and so compounds X and Y are going to end up closer together on the chromatogram, and that's what you needed to talk about to earn the point for part C. How did you do? So the average score on question number 7 in 2024 was 2.03 points out of 4, so just about 50%. If you earned 2 points, you're right on track with everybody else. If you earned 3 points, you're doing well. 4 points, you had to really know your chromatography to do this question and earn all 4 points. If you found this helpful, like the video and leave a comment, and subscribe to my channel so you get all my latest updates. Have a great day and keep studying chemistry.